Good morning, ladies and gentlemen. Welcome to the BCA-SIA-ACES free bite-sized webinar series, Staying the Course in Unprecedented Times. My name is Hui Wen from BCA Academy. We are very grateful to have Singapore Institute of Architects, SIA, and Association of Consulting Engineers Singapore, ACES, in joining us today to organize these live webinars and, more importantly, to engage the built environment practitioners like all of you to support your continual professional development in these trying times for the industry. Today is our first webinar series, Heightening Community Resilience through Environmental Sustainability for Green Buildings. Before we proceed, here's a quick flash poll to gather everyone's view on how the current pandemic situation has impacted you and what is important to you post-COVID-19. There are a total of 5 questions, and you can select more than one option for each question. Thank you for your active participation. Here's a summary of the results. Majority of you think that the built environment sector has indeed impacted much from the COVID-19, and it is important to build out capabilities on leadership development. We shall keep your response in mind for future consideration. Let's get back to our webinar series. There are some administrative matters for all to note. Let me highlight that as participants, you are on mute setting. Should you have any questions about the discussion topics, you may do so by clicking the raise hand or Q&A button on your screen. At the end of the 2 presentations, the webinar chair and panel of speakers will address to it. You may also direct your questions directly to the speakers. Here's an overview of today's program. We are pleased to have distinguished speakers like Dr. Zuraimi Sultan, Program Director, Berkeley Education Alliance for Research in Singapore, and architect Tan Hann, Council Member and Chairman of the Sustainability Committee of SIA, to share with us on how the current pandemic situation has opened up new opportunities for us to transform and heighten community resilience through environmental sustainability in green buildings. Together on board, we have architect Leong-Kok Su-Ming, Managing Director of BCA Academy, to chair the session. As an introduction, Su-Ming is the Managing Director, BCA Academy, the education arm of the BCA. She oversees capability development of specialists and building professionals through a comprehensive suite of programs. Without delay, let us invite our webinar chair to deliver her welcome remarks. MD, please.
Good morning, everyone. Welcome to the webinar series. I hope everyone is staying safe and staying home and also having a productive and meaningful time. As the world comes to terms with this global pandemic that has really threatened our lives and for some our livelihood upside down, it is clear that we will almost certainly not go back to the way things were. The shocks to the system that we are experiencing now and will continue to anticipate raises many questions about the things that we have taken for granted. If at all, a possible takeaway from this crisis is that we can take the time to reflect on our practices, examine the disruptions that we face, and reset our expectations for the future. This webinar series is thus envisioned as a platform for practitioners of the sector to touch base and to build consensus as we discuss the impact of the crisis on the developmental trajectories in the short and the longer term. There is greater urgency to recognize the importance of taking a whole system view with the emerging clarity about the interdependence and what we value as a society and as a sector, and where the complex narratives need to integrate or intersect, and where all these needs to be fundamentally mapped together. As a sector, we may now need to play out in a new paradigm where transformational changes will take place on whole new possibilities. As part of this series, we have curated 6 bite-sized talks across these 3 days in this week to catalyze discussions on responses by the built environment sector across the life cycle of a building, be it from planning to operations or through the adoption of technological or digital solutions. I'm thankful for the partnership of SIA, coordinated through CK, and ACES, coordinated through Teo Yen, in the urgent putting together of this webinar series. If our current system has revealed to us there is a certain lack of resilience as we go through the COVID pandemic. It reminds us that what we are experiencing now may just be a mere dress rehearsal for the system shocks that lie ahead that can potentially be unleashed by the crisis of climate change, leading to far more impactful collapse of the whole ecosystem. It is in this decade that we have earmarked to make progress in the UN Sustainable Development Goals. And let's take this pandemic as a wake-up call to collectively chart the future we value and desire within our cities and in our buildings. With this, let me dive straight into introducing our first speaker for this section, Dr. Zuraimi Sultan. Dr. Zuraimi is the Program Director of SINBERBEST, which is based here in Singapore, where it is an alliance with Berkeley and US. The main activities involved are 5 deeply interconnected human teams, human building nexus, enhancing our health and productivity in the built environment, from the angle of smart technologies to be able to be agile, intelligent, efficient, and resilient, as well as the incorporation of design and operation of building envelopes for energy efficiency and human comfort, data analytics for the built environment, and the cyber physical test bed and large-scale development. Without further ado, I'll hand over the time to Dr. Zuraimi, who will speak on the topic of Shaping the Future with the Green Buildings, Lessons from the Challenges of COVID-19 Pandemic on the Built Environment. Dr. Zuraimi, over to you, please.
Thanks for the introduction, and also thanks for listening in. Now, before I proceed, I would like to acknowledge I would like to acknowledge the others from the Simple Best group who are also involved in this activity. So this will be the outline of my presentation today. I will start with the background situation, and then we will discuss briefly about the transmission routes for COVID-19 virus, provide recent studies on COVID-19 virus related to indoor air, and then I will describe the precautionary document and recommendations for building operations. And lastly, we look forward to hearing feedback from the building community. Now, public health experts have said that the best way to describe our situation right now is that in the pandemic as also the crisis, is that all of us are now on a boat which has capsized. And then we are all right now on a life raft, which is a metaphor for current interventions such as social distancing, stay at home. While we are on that raft, we are also casting our eyes to the shore, trying to find dry, safe land, which is a metaphor for widespread immunity of the population to this disease. Now, how do we get there? It's a very big problem that many experts and policymakers is trying to solve. Now, obviously, if we have acquired herd immunity or discovered an effective cure or vaccine, then the problem will be solved. But however, recent serological prevalence studies overseas and here in Singapore shows that the communal immunity is very, very low. That means we have not achieved herd immunity. And also, with regards to vaccination, experts in March have said that the vaccine will not be ready until 12 to 18 months. So what's going to happen in the meantime, what's going to happen to Singapore's economy? What can be useful is that we can craft a set of interventions or procedures that will allow the economy to come back while controlling the virus. Now that is a very big challenge. In the context for today's talk, we should be making the building resilient for people to be in and until we reach our widespread immunity. So the World Health Organization is very clear that the main routes of transmission is through large expiratory droplets and surfaces contaminated with the virus. For this reason, governments have until now recommended social distancing and hand washing as the two main means of limiting the transmission of COVID-19. But there are other organizations that say that states that the transmission through the air can happen, as you can read here. The American Society of Heating, Refrigerating, and Air Conditioning Engineers provided the following position, explaining that the transmission through the air is likely and that HVAC systems can play an important role. And we are beginning to see new studies, research studies that support this position, which I will share very quickly in the next few slides. Now, this is the first study that's published in the Journal of American Medicine Association. It is a study that's conducted here in Singapore in isolation rooms of several patients with mild symptoms. They took environmental samples from various surfaces and also sampled the air. What they found was that the toilet bowl and sink samples were positive for the presence of the virus. When they sampled the air, it was negative. However, the swabs taken from the air exhaust vents outlets, which could be about 2.7 meters in height, and these swab samples were positive. This suggests that the small virus-laden droplets may be displaced by airflows and deposited on equipment such as the vents. Now, this is another study that showed that the aerosols of COVID-19 virus can remain viable. That means they are living in the air for 3 hours. This is a very profound finding because you compare that 3 hours with a typical ventilation rate of an office building, which may range between 0.5 air exchange rate per hour to 1 or 2 air exchange rate per hour. This is another study that's published in 2 hospital wards in Wuhan during the outbreak. Shows large contamination in the ICU compared to the general wards. But most importantly, the researchers found that the virus can be detected in the air 4 meters away from the patients. So this is another study that was conducted again in the Wuhan hospitals during the outbreak, just recently published. They found that the medical staff areas had high concentrations of virus in the air, where the particles size distribution show peaks at the submicron levels, which, by the way, submicron particles can remain in the air for a very, very long time. The investigators indicated that room ventilation can limit the concentration of the COVID-19 virus in the air. So about half a month ago, and as the evidence began to grow, we decided to develop this document for Singapore based on a precautionary approach. It is a non-mandatory document and just include a set of recommendations for building operations. The principle behind this document is that it's basically talking about reducing risks, not eliminating risks. Recommendations are made with imperfect data specific to COVID-19 virus. Yet our recommendations are also grounded in many years of science and research and experience from the field of indoor air quality, mechanical engineering, and exposure science, and also based on past studies on other infectious diseases like influenza, measles, and tuberculosis. So the building applications in this document, just to add on further, is that it is applicable for office, schools, childcare, residences, as well as dormitories. Right now, we focus on the circuit breaker period, mainly to protect essential occupants in buildings, to ensure the function of critical services. We also provide guidance to those who need it, especially for homeowners and institutional buildings like childcare and schools. And lastly, we want to obtain feedback from the building industry to allow us to refine the document as we move forward. Lastly, and most importantly, is that we note that this document should not be used in isolation to other Ministry of Health recommendations in terms of hygiene, social distancing, and disinfection measures. Rather, this document should supplement those main recommendations by MOH. So go ahead, clean your hands, stay 1 meter apart, wear your mask, and stay at home. Do all those things first, and then adopt these guidelines. So what's inside this guideline here? First, we recommend to increase the ventilation in buildings, outdoor air ventilation. Because solution to pollution is dilution, that's the basis here. In buildings with air conditioning and mechanical ventilation systems, we recommend that the outdoor air supply to be set to the maximum setting to enhance the dilution indoors. We recommend the operation times to be extended to commence beginning 2 hours before the first occupant come in, and switch off 2 hours after all the occupants have left. If you have demand control ventilation and features that only turn on the supply air when the occupants are in the room, this should be disengaged. Secondly, we recommend to minimize recirculation in air-conditioned buildings. If we have a source of virus from within the office and and the air containing the virus gets entrained into the return air. We don't want the contaminated return air to be mixed with the supply air and get back into the office. So for air-conditioned buildings that have the capacity to operate with 100% outdoor air, they should be operated in such conditions. If full closing of the recirculation air is not possible because of for adequate comfort, thermal comfort, or the system cannot, the system constraints, the recirculation air should be kept at a minimum level, and then the air shall be treated with high efficiency media filters or localized portable air cleaning technologies, which I will talk about in the next few slides. Next recommendation is related to the previous recirculation topic. This has to do with the rotary heat exchangers or heat wheels. The original intent of the recovery heat wheel is to recover heat or moisture from different air streams for energy savings. But under the COVID situation, we do not want to recover more than heat and moisture. So to prevent the exhaust or recirculated air that may contain the virus from getting entrained into the supply air, we recommend that the heat wheels or heat exchangers to be switched off. Also, we recommend that any possible leaks within the heat wheels, that they shall be identified, and then these heat wheels, the leaks within the recovery wheels, then should be sealed properly. Next, we recommend that for natural ventilated buildings with operable windows, that the windows are fully open to allow air to flow indoors. Of course, when you do this, be mindful of safety requirements, and also be mindful of the outdoor noise and air pollution. You ensure that there's no obstacles in the path of the air streams, and you can use increased air motion, such as the use of ceiling fan, standing fan, or desk fans. For air conditioning if air conditioning is used in buildings that are designed to be naturally ventilated, like HDB buildings, we recommend that sufficient outdoor air be provided by keeping the windows a bit open in every room to provide a little bit of comfort. Next recommendation is to use high quality, efficient media air filters. ASHRAE standard test efficiencies of various filters in terms of their performance to remove particles of various particle size, and then they will assign a MERV rating to these filters. So it is necessary to know how well these filters will perform for COVID-19 virus. As you can see here, the COVID-19 virus particle has an aerodynamic diameter of about 0.07 to 0.12 microns. So 0.12 microns is given by the red dot over here, red dot line. But then the virus may also exist in larger droplets up to 1 millimeter in size. So in our guidance document, we recommend the use of high efficiency media filter, preferably MERV 14 and above, that they are installed and operated in the air handling unit that serves the return air and as well as the outdoor air. Also, another important thing is how we install these filters. In this regard, we should properly install the filters and ensure that they are well sealed to prevent filter bypass. If the filters shall be regularly inspected to ensure that there's no leakage and that's not fully loaded. All this can help to make sure that we can achieve the full benefit of the performance of the filters. Next is on the UVGI, ultraviolet germicidal irradiation. We know the virus will be inactivated by UV light, particularly at the 262 nanometers in wavelength. There has been a long history for the use of UVGI use, and many studies, scientific studies have been published So it makes sense to recommend the use of UVGI. So in buildings, we can install UVGI, whether they are portable UVGI, upper room UVGI, in the air handling unit, or in the ventilation duct airstream. Just ensure that the UVGIs are professionally installed, as direct UV exposure can be harmful. Now, portable air cleaners definitely have a role. It has a role for several reasons, because one is that they can be used in a smaller space like a bedroom or a small office, which might be easier to treat the air than compared to a big office. Secondly, you can put them in a space with an infected person or a susceptible person, because it effectively cleans the air within the vicinity, within the immediate vicinity. And lastly, it is useful for residential buildings, because in Singapore, most HDB buildings do not have mechanical ventilation systems, and this will be very useful. We recommend the use of portable air cleaners that move a lot of air. So the performance here you look at is called the CADR, which stands for Clean Air Delivery Rate. CADR, it has a value. So we recommend a CADR value. So when you purchase the portable air cleaner, there's a CADR value at the start of the box, and from then you will recommend what type of volume of space for its effective use. In other words, you're supposed to choose portables that have CADR that commensurate with the volume of that space. Not to use them in a space that's bigger than what it can do. And also, last word, there are a lot of technologies that are being used for portable air cleaners. In this regard, we recommend the use of HEPA-based portable air cleaners, high efficiency particulate arrestants portable-based air cleaners. Now, one of the minor routes of transmission that the WHO and CDC has mentioned is the fecal oral transmission. This is in a recent study, they showed that a significant portion of people with COVID-19, they experience a lot of diarrhea and vomiting, and before the onset respiratory symptoms. And then the researchers found that the genetic material for the virus can be found in the fecal samples, the stools, indicating that the virus has been shedded into the fecal matter. So what this means that when we flush the toilet, when we flush the toilet, the virus could potentially be aerosolized into the air and be transferred elsewhere. The same way as what has happened back in 2003 in the first SARS situation in Hong Kong at the Amoy Gardens apartment. So in this document, we recommend that the exhaust ventilation should always be kept on and ensure that the toilet is under pressure to minimize risk of fecal oral transmission. Now, another recommendation to consider is the airflow pathway distribution during in the buildings. This is based on a recent study in a restaurant in China where 3 families were subsequently found to be infected with COVID-19 after eating lunch at this particular restaurant. So, and you can see from the top of this figure here, the carrier is sitting among the 3 table zones. It so happened to be that the table zones are the most poorly ventilated end of the restaurant, and the air is recirculated at that portion. Their results show that the infection distribution is consistent with the spread pattern representative of the exhaled COVID virus. And lastly, we provide recommendations for residents with persons of interest. We define POI as those on stay-home notice or leave of absence, or those who are displaying COVID-19-like symptoms, not COVID-19 positive cases. So all the room in the windows of the POI shall be open without opening the doors that links to the rest of the house. Again, safety consideration should be applied here. We recommend the use of high-efficiency HEPA-based portable air cleaners in the room of the POI. and also the use of portable or upper room UVGI in the room while still taking into precaution of safety in its use. So in summary, we have developed this precautionary document for Singapore building operations under the circuit breaker. We would like to reiterate that the document is meant to supplement other MOH guidelines that have been instituted. So the document should never be used in isolation or considered as the main go-to guideline to handle this crisis. You can download the document from the Super Low Energy Building website here. We would like, in this regard, we would like to thank BCA for the support and putting this document on this platform so people can access. And with regards to that, we view that this document as a living document, especially as more data gets published. We will continue to refine it and adjust any prior recommendations. And in the meantime, we will also welcome feedback from the building industry, especially for this document. And if we welcome participation in research with us in this area as well. The next step for us is to formulate additional guidelines for building operations, not just under the circuit breaker mode, but beyond that. Then with that, I conclude this presentation and I thank you for your attention.
Thank you, Dr. Zuraimi. Your sharing on the precautionary principles related to COVID-19 spread within Singapore buildings is so relevant to us. Next up, Su-Ming will introduce the next presentation topic and speaker. MD, please.
Hi, I'm back. Well, thank you very much, Dr. Zuraimi. Next, I would like to introduce Hann, who is our next speaker, and he's the chairman of the SIA Sustainability Committee, and also a board member of the Singapore Green Building Council. Of course, everyone knows Hann is an award-winning architect and a thought leader in sustainability, working on a variety of cutting-edge projects, and he is currently working on sustainable development for a leading hospitality chain. Hann was appointed the World City Summit Young Leader and is one of the Built Environment Young Leaders as well. He's also the BCA-SGP's Young Green Architect Award winner back in 2015 and 16, and his portfolio includes the award-winning Park Royal on Pickering together with Woha, as well as the BCA Skylab, a rotatable test bed facility for new technologies. So without further ado, I'll hand over the time to Hann, who will talk about life after COVID-19, 7 guidelines for a more sustainable and self-sustaining future. Hann, over to you, please.
Hi, thank you, Su-Ming, and thank you everyone for turning up this noon. I hope I won't take too much time, that will eat into your lunch. Can I have the slides on? Yeah, so today I'm gonna sort of take a slight step back from Dr. Zuraimi's presentation that has gone into quite a bit of detail as to what we can do with our spaces. This is a bit of a broader guideline on how architecture can actually respond, or how green buildings can actually respond to a global pandemic. Of course, this pandemic in question right now being COVID-19, but what else can we do and what other principles could we set ourselves up should, touch wood, another global pandemic actually hit, or another wave of COVID-19 actually hit. These are guided by the United Nations SDGs, Sustainable Development Goals, right? So at the SIA, at the Singapore Institute of Architects, we've actually come up with 7 guidelines for how buildings can be sustainable. So of course, everyone needs a feel-good story these days. I mean, we've been stuck at home largely for 4 weeks with another 4 weeks to go. So good job, us. There's 50% through, right? But we've always been milking for good feel-good stories. For instance, the otters coming right into the center of town. I think they visited Mustafa recently. Someone should have sent them the memo. Also deer coming into cities and wildlife really taking over the urban landscape once again. But of course, some of that is exaggerated. A lot of that also is basically, feel good news. Carbon emissions, sorry if I can go back to the previous slide. So carbon emissions have been recorded to fall by about 6% month on month. They're falling quite significantly, even if it's 6%, but not for long, because once the cities or once the countries stop locking down, there's anticipated rebound as well of industrial activity. So thanks to COVID-19, it's also time to flatten the curve on climate change. And if we look at the next article, the analogy between COVID-19 and climate change is eerily precise. So here's an article from Wired. And that's because a lot of response from governments is basically to deny the problem or to play it down, right? And if you remember back in the 90s, climate change was actually global warming. And even then, the term itself gives you a false sense of security because it's only warming as opposed to heating, for instance. And then they changed that term again to consider it climate change instead of global warming. So psychologically, you feel, hey, change is necessary and it's something we have to deal with. So that, as an outcome, basically just denies or mitigates the problem, or reduces the problem, I'd say. And then after that, we'll come back and say, hey, the solution is too expensive, right? So the same thing happens, as you can see globally right now, with how COVID-19 is being dealt with as well. Now, I cannot consider myself a healthcare expert. I won't reiterate the measures that need to be put in place, but what then can green buildings actually do to stop the spread or to flatten the curve, as it were? So if there's collective response, it's a question also about policy, it's a question of healthcare systems, right? And also the societal makeup and societal culture. Likewise with climate change, if we go business as usual, the risk is high. In fact, it may not dip, it would go up exponentially. And the Paris Agreement sort of draws an underline as to keeping the global warming temperatures to less than 2 degrees Celsius. And there's a sub-movement to that tries to keep it within 1.5 degrees Celsius, right? So if likewise we adopt the same practices on COVID-19, could we actually do that for a larger future problem, which is, current problem with a longer term implication, which is climate change? So global temperatures will rise by 4 degrees Celsius by 2100 from 1900 if our activity continues. COVID has just put a minor or temporal stop to that. By 2025, 2 out of 3 people would have no access to clean water, right, globally. So right now I'm looking at the attendees list, there's close to 800. So that means 500 odd people would have no more access to clean water in 5 years. Over 80% of the world's fisheries are fully exploited. A refuse truck worth of plastic is dumped into the ocean every minute. By 2050, there'll be more plastic than fish in the sea. And especially for us in the building industry, concrete can be argued to be the most destructive construction material on Earth, right? So if anything, COVID has put to light, these factors that, hey, we are over-consuming, we are over-industrializing, and therefore, there are theories where this is a result of what we're actually doing to the planet. And speaking of the planet, climate change isn't just the main challenge that we face. If you look at the planetary boundaries model, there are 9 different sectors where the impact of what we're actually doing as human beings on the natural landscape or the natural ecosystem, this is actually recorded as how much risk we're actually facing. So if you look at the zones in red, these are hitting the zones of, or have gone beyond the zones of uncertainty. And what happens if you go beyond the zone of uncertainty is the planet tends to want to hit the reset button. And the last time that happened, of course, we lost a whole dinosaur population. But basically, we're looking at biosphere integrity and biogeochemical flows. We're doing so much to the planet that we can't even track anymore, right? Compare that to climate change, where yes, indeed, it is an urgent issue to deal with, but we're still beyond, or rather below, the zone of uncertainty, right? So look at this slide for a moment and look at what we're doing as an industry in terms of building. So the work we do at SIA in the Sustainability Committee actually tries to angle these issues into the scope of building, right? How if a building indeed can be designed to be more sustainable or adopting the principles of the not just planetary boundaries model, but also the UN Sustainable Development Goals, which you'll see in this slide, right? There are 17 goals that are aimed, very lofty, some of them, to be honest, that are aimed for basically the global sustainable development principles, right? So if you look at some things, there are some things that architecture and building can do. There are some things that we can try, but it's a bit tough to try to achieve peace and justice by designing green buildings, for example, right? And gender equality in the workplace, definitely, but it's something that goes beyond architecture as well and beyond green buildings. So we look at 7 principles that within the scope of green buildings, we can actually try to, integrate and try to promote these values, right? While at the same time developing resilience, especially in a time of a pandemic, but also in the longer term run of the climate change issue that we're currently facing, right? So why 7 goals? You might have heard of the 7 habits of highly effective people, right? Some of these habits are no longer as effective because everyone's sort of holed up at home, but 7 is fairly easy to remember. And also it becomes a sort of a guidebook, which I'll share very shortly. So the first of which is education and integration. So in this case, of course, it being an architecture document, the architect or the developer, or in this case, the consultants, they have lead roles in integrating and educating the client and the team, leading the design process, and actually putting these sustainability goals up front. So how do we measure that? We measure that by a level of development for BIM, for instance, in terms of integration. We develop these sustainability goals through collaborative appointments and also through design charrettes. And how we then measure is basically through some of these values, right? Design responsibilities, BIM, as well as ECI, early contractor involvement, and early facilities management involvement as well. So bottom part of the slide is where you can see some of the goals being integrated as well. Some of the projects that are undertaken would include, in this case, the SIA Green Book. So this basically is a guidebook that influences how sustainability can actually drive the design and construction process, right? And this book will actually launch on the 21st of this month by the SIA. It will be a free copy, and that will be extended to BCA as well for further distribution as a guidebook. Other projects that are in build form could include the BCA Skylab, for instance. So this basically integrates research, development, and building. So it's a test laboratory. It actually rotates as well. So what it can do is you can incorporate new technologies and see how that performs in a real world scenario. So that takes a bit of the academic side of things, the research side of things, into the build side of things as well, that then the industry can then continue to adopt. The second, of course, is the climate action. That's a big goal. So us building experts, being the custodians of the built environment, should lead the change. And the metrics could include low operational carbon, metric tons of carbon dioxide emissions, for instance, effective life cycle assessment, right? And also carbon counting, and basically looking at how much embodied carbon there is in the construction and also in the operations of the building, right? So that looks at the climate action side of things. Some projects, or some examples really, that could be your projects too. This would be set up in a master plan project, for instance, where you set the limits of the carbon that's actually being emitted in the construction or in the planning of the master plan, and also introducing architectural principles such as distancing between buildings, such as the facade ratios and so on, and also replacement of renewable energy. And basically, what this does is it sets up a rubric where the master plan becomes the environmental control of the project itself. On a building level, of course, it could also translate to energy operations. In this case, a data center project in India, where the data center itself is actually cooled by the cooler ambient air temperature, right? So basically looking at engineering as well as architectural integration. The third goal would be natural capital. So that's preserving biodiversity, one of the 9 sectors that you saw in the earlier planetary boundaries model. So as leaders of the built industry, the architects and engineers should need to address ecological impact of our built environment, right? So that plays a big part in the guideline as well. So we're looking at metrics such as the Singapore Index for Biodiversity in terms of wildlife protection, as well as wildlife preservation, landscape replacement, green plot ratio, that's already part of a green mark. Likewise, measurables such as leaf area index and a landscape replacement, that too part of the green mark scheme. So that integrates life below water as well as life on land as part of the UN SDGs. Some examples, of course, would be taking green to the skies, in this case, integrating that with the interactable landscape within the building as well. The fourth goal would be resource management, right? So basically looking at how we look at materials, not just from cradle to grave, but also cradle to cradle, meaning the end of the building's life cycle could find its way into a new life in a brand new building, for instance, right? So the metrics would be percentage replacement, energy utilization index benchmark, for water, likewise with water efficiency, and for materials, local sourcing as well as renewables, right? With the possibility of responsible consumption and recyclability, right? So these are, again, the SDGs. Some examples where waste materials actually used for buildings as well. So in this case, a building that's made out of recycled plastic water bottles, right? That becomes an exhibition hall and potentially also a multi-purpose hall in the case of COVID-19, where we actually need to house new healthcare facilities as well. So the same materials could also find their way into interior furniture and fittings, right? In this case, the chair that you see in the middle of the screen is basically made out of recycled rice husks with recycled PET bottles, right? And likewise with demolition stone that you could compress. The one on the right is actually also made out of recycled PET that then becomes a fabric that could become an acoustic performing material as well. So that's looking at material resourcing. And of course, these materials could also come in various HEPA filters in your air conditioning and your supply systems. The fifth goal is urban harmony. So that's basically integrating with not just the existing landscape, but also creating opportunities for new urban connection, right? So this is almost like architecture 101 or building 101, where you basically are mindful of what's happening in the neighborhood and how the introduction of a new construction could actually enhance the life of the community, right? So the measurables would include connectivity, placemaking, as well as diminishing the urban heat island impact. So an example where basically the building has naturally ventilated lungs, so to speak, in the courtyards, which also creates areas for social connection and for chance meeting as well, especially in the context of HDB block, right? Hopefully that will be the case once again, once we get past this pandemic challenge. All right, we're getting towards the end here. So basically health and well-being, right? Of course, this is something that is at the forefront of discussions of green buildings these days. So basically, this is a way to actually promote physiological as well as psychological wellness, emotional satisfaction, and safety, right? So we have a few codes of practice that actually look at that as well. So that includes universal access, that includes green mark for healthcare facilities, and also the various wellness aspects that it actually incorporates. So the measurables will include biophilia, comfort, inclusiveness, and safety. And some examples really would be, again, introducing natural materials into the interiors and visual connection to green, right? So if you subscribe to the biophilia theory, if you look out your window now that you're stuck at home, and if you've got visual access to green, that will actually improve your psychological health. And also aspects in the workplace, such as promoting the circadian lighting, right, that your body clock could actually respond to as well. So by the evening, for instance, instead of continuing to work, you have lighting that becomes a nice shade of pink or a nice shade of orange, like the sunset, and then your body clock would be able to know that, hey, evening is coming. So an example of a proposal for a hospital in India as well, wherein the healthcare is, or rather the nature of healthcare is created through every single ward having access to greenery in this case, and also the creation of little spa pods where long-term patients can actually get their treatment for relaxation and for wellness as well. And finally, of course, given that climate change is a long-term problem, we look at adaptability and longevity, where the building is designed for flexibility and adaptive reuse, right? And basically we look at these metrics designed for maintainability, UNESCO Historic Urban Landscape as a guideline, right, on the prolonged life cycle and the protection of buildings, right? So that of course, encapsulates good jobs and economic growth, innovation and infrastructure, as well as responsible consumption as part of the UN SDGs as well. Right, so some examples would be conservation, of course, preserving existing buildings and constructing only where it's necessary, and you could actually do A&A to the interior spaces otherwise, so that preserves both a structural integrity as well as a cultural integrity of the building. And also adapting A&A, instead of constructing a brand new building, for instance, preserving the structure, and in this case, adding 2 new stories to the building with the potential for more, because buildings, in this case, the original building in the 70s was designed for a higher structural load, maybe with an enhanced safety factor as well. So the case here was a reduction in the overall construction cost as a result of the preservation of the structure, right? So that was reduced by about 20%. So a quick summary, these are the 7 environmental design guidelines by SIA. So again, that basically encapsulates most of the UN Sustainable Development Goals. And the idea is it needs to basically extend across the entire project timeline and a building life cycle as well. So when we were talking about materials and the preservation of natural capital, right? So also often we're so used to taking, making, consuming, and then disposing. What can we do to actually loop back, in this case, the waste that's actually recyclable and bringing that back into the loop? So that basically underpins the concept of the circular economy. And earlier we talked about the 9 sectors of the planetary boundaries model. This is a model that overlaps a donut on top of it. So at the base of that donut, if we go below or beneath that base, that basically goes beneath the social foundation, right? So beneath that, the lifestyles of human beings, or the very basic requirements of human beings, are then compromised. But then if we exceed the outer circle too much, right, we're exceeding the ecological ceiling, and we're putting in danger all these different aspects of the environment, right? So the idea of the donut economy is to look at growth as little waves within this green zone, which is within that donut that we speak about. And that's by an economist called Kate Raworth. And it's worthwhile reading, because how do we then adapt green buildings, especially in the case of a global pandemic, within a growth that is equitable and also that's sustainable for the environment? So in the last, how much time have I left? I think I've got 5 minutes left, or maybe even less. We'll look at a quick exercise that was actually done by the Sustainability Committee in the past 2 weeks on looking at what kind of building typology can actually expand, or rather can adapt to a situation of COVID-19 in a way that preempts rather than reacts to any global pandemic, right? So one of the possible social arguments as to why this is happening is because of income disparity, not of how the virus was released, and we'll get into that, but basically how the treatment or how the control of the virus spread is actually achieved, right? So of course, disparity leads to different modes of living. Disparity also leads to high concentrations, or rather the wealth of certain nations leads to high concentrations of travel that becomes a natural vector for the spread of the virus. And also, in this case, the image of a favela that, the text is not coming up, there you go, right? So the favela basically becomes a hotbed of disease spread as well. That also ties back to various economies and how their different densities are. And if you look at the natural response, the response so far is containment, and Dr. Zuraimi alluded to that as well, right? But that falls outside of the natural habitats of so many in the world. So instead of natural containment, how do we create an expandable system that, first of all, allows for natural ventilation, as has been mentioned previously, and also allows for expandability, where any facility, for instance, can then become a healthcare facility overnight, right? So we looked at the Dewan, in this case, a Sanskrit word for the hall or the ancient forum, right, that originated in southern India, or in southern Asia rather, and how we can basically use that as a new modular typology, right? So in the planning of healthcare facilities, for instance, we'd basically be looking at the placement and how they can be distributed in any city plan for equidistant access, and also in the master planning allow for access from around the block as well. So it becomes a fully permeable building in that sense, right? So you could introduce containment, and you could also introduce flexibility. So multiple points of vehicular and pedestrian entry, around access for traffic redirection and management in times of a crisis, sufficient space to organize front of house, back of house, and so on. And this becomes therefore a modular grid. And finally, areas for temporary expansion or supporting infrastructure. Right. So the next slide actually shows some of these principles. The building height should be medium in case of an earthquake risk. Right. The massing also expandable. Additional resilience through bracing, for instance, in earthquake-hit environments. The facades can be fairly open, right, to encourage natural ventilation. The roofs also with sufficient loading for the possible expandability and also creation of outdoor evacuation areas. Sorry, there's a bit of a lag in the slides. Here we go. And finally, circulation, interior spaces to be open plan, and that also allows for the intersection of different volumes for different purposes. Sorry, I'm just going back to the previous slide again. Yep, and of course, natural ventilation. So you protect certain areas of encroachment or of entrapment and catchment as you were, right? But to prevent the spread of the virus or what have you within any given building type as well, a natural ventilation would then be encouraged, right? Unless, of course, it is proven to be airborne. Right, so this basically encapsulates that concept. So you see different uses within and different adaptability concepts as well, access for emergency vehicles, and also the possibility of rooftops where you can start building self-sustaining agriculture or self-sustaining infrastructure as well. And this encapsulates, in this case, the 7 EDGs. So as a quick summary, climate change is indeed a larger, more long-term problem. And for so long as we have this issue, we won't be able to run away from global pandemic issues. So the rich-poor divide has led to saturated communities. Urban sprawl may not be the solution, right? Even though it creates distance, but it also starts to erode natural habitats as well. So modular buildings could be one possible solution out of many, and these adaptations need to respect and respond to nature. Yeah, so with that, I think green buildings do have agency, or we do have a part to play in the fight against COVID-19. We aren't exactly frontline. If we were, we wouldn't be sitting here today. But what we can do is to plan again for the next 50, 100 years, and hopefully building as infrastructure could better prepare us for the next global pandemic. Thank you very much.
Thank you, Zuhan, for your intuitive 7 environmental design guidelines. Right now, we will move on to the Q&A session. You may raise your question by clicking the raise hand or Q&A button on your screen. Over to you, MD.
Well, thank you very much, Zuhan and Dr. Zuraimi, for the very interesting sharing. I think from the very macro perspective, looking at how the Earth responds, or the built environment sector responds to a pandemic, all the way down to the inner workings of a building typology, and how we should review and relook at some of the ways we ventilate our buildings, or we design our buildings through passive and active means, so that we can make our buildings more responsive to the various threats to the communities, or to adapt better to any change of use or flexibility of use as we face different crises. As mentioned by the Secretary, the Q&A panel is open. And so if there are questions that anyone would like to ask, you can hands up and we'll try to put you through. I think based on the questions that are there, perhaps I can direct you to the question from Su-Ming, which talks about the adjustment to the ventilation within buildings. And what is the, sorry, it's actually from Jason, as well as a few others, on the recommendations for the revised ventilation modes in a building, and how this would affect energy efficiency and performance of these buildings. Perhaps you can share a bit more from that angle.
You first, Dr. Zuraimi.
Yeah, thanks. Yeah, I think right now at this stage, our recommendations is we need to improve, increase the outdoor air intake into the buildings. Obviously, there's some energy implications for that, but primarily this document is meant to reduce the risk of COVID-19 transmission. And right now, we're working on trying to make sure that these recommendations are sustainable over the long run. So we're planning to do some building simulation levels to see what's the impact of increasing the ventilation rate on the energy consumption within buildings. And as soon as we get more information, we'll refine the document as we proceed further.
Thanks, Dr. Zuraimi. There is another question that talks about whether there is any increase in energy consumption with the revised ventilation mode. Would you want to share a bit about that angle as well?
Yes, sure. As mentioned before, as we increase the ventilation rate, in particular for the mechanical ventilation building, air-conditioned mechanical ventilation buildings, we could theoretically expect an increase in energy consumption. So, so again, our document recommends, and this is non-mandatory, but the main purpose of the document is to reduce the risk of COVID-19 transmission within buildings. We will continue to work with various building industries members to make sure that our recommendations moving forward are also aligned in terms of their sustainability approaches as well.
Great. I think it will be a new dynamics or a new paradigm to look at balancing all the contrasting or the interrelated requirements as we relook at the building. And I think that's exactly what was shared earlier. Perhaps maybe to take the discussion a bit back to look at, if we look at the urban level or the more macro level within a certain precinct or within a cluster of buildings, what are some of the new considerations or revised way to consider the demands of the community, the users, flexibility in adapting the built environment when we look at passive solutions or active solutions at that scale in the design of upcoming buildings? Perhaps either of the speakers can share.
Well, I think the guidelines don't take away the other aspects that one would consider when actually planning for and designing a building. Right? So a lot of that is still driven by the brief. What the guidelines actually do is to create a new layer of consideration of what the act of building is actually doing to plan it, right? And how, if we actually endeavor to get that right, that could actually help the occupants as well in terms of the, of course, healthcare aspects as well as the wellness aspects. I think it's a bit of a two-way conversation, right? There are many instances where right now the design of better buildings could actually have led to a more controlled spread of the disease, for instance, right? Or the better planning, in this case, not just of cities, but also of policies and of individual buildings, right? Could enhance wellness. And I think fundamentally, if we go down to, the quarantine issue that many countries are actually adopting, right? Basic guidelines for how your own home could actually be built would also be beneficial.
Dr. Zuraimi, you have something to add?
Yeah, I think the response by Suhan is very appropriate. It's quite encompassing. I got nothing to add. Thank you.
Thank you. I think we have some questions from our participants. Can I again urge everyone to join the discussion and to leave the administrative questions to later? So perhaps to start off the questions from the floor, can I invite Mr. Roger Riganan, who would like to ask a question? Roger, over to you. I think your mic is muted, Roger.
Maybe while Roger is figuring out the mic, there's a question from Jeannie Kwok on whether there's increased interest to finance more green building design during or after the COVID-19 recovery period. I would say while we're still doing the damage assessment of what COVID-19 is actually doing to the industry, I would hope in the longer term there would be more mechanisms or more instruments of green financing as well, because clearly that ties back into human health and ultimately, the downstream issues of productivity and, basically how valuable in this case your building occupants as well as the building itself is going to be. So I'll definitely hope for that.
Yeah, exactly. Because I think there's a lot more value to look at buildings providing protection against risks of pandemics or enhancing well-being of occupants. So probably we will really have to look at funding or financing from a more holistic angle.
Sure, and also I would like to add that the line of questionings that I've been receiving from the questioners, questions seem to be more heavy on the side of what's the impact on the energy efficiency. Although it's very important, I mean, in terms of the climate change, these are all very important. But when we design buildings for people to be in, and they have to be basically safe for the people to work in.
That's true. Safety first, right? Okay, let's move to the next listener who want to ask a question, Mr. Sapu Pillai. Sapu, would you like to ask the question? I'm not sure whether there are technical issues or... Mr. Sapu Pillai, are you?
Yeah, no question.
Oh, no
Thanks.
question.
Thanks.
Okay, then let's move to Mr. Shanmugam Mahash Babu.
No question.
Sorry, no question.
No.
Perhaps the Secretariat will help us to lower the hands. And then those who have questions to put up again, perhaps, I don't know, earlier, maybe some people have put up hands accidentally. Okay, let's start with Mr. Gana Prakasam. You have a question?
Hello, can you hear me? Okay.
Yes, we hear you.
Yeah, I have a question with Mr. Tan. He's talking about the space. We want to give sufficient space for the buildings and all things, the escape routes. And in Singapore, we have very limited space. How we can explore to that with the limited heights and with sufficient space?
Yeah. Actually, if you look back at the population density or the amount of actual real estate area that each one of us in Singapore actually occupies, it is not that little, to be honest, right? It's actually
8,000 per square meter, 8,376 per square meter, if I am not wrong. Almost above 8,000. India is 400.
Mm-hmm. Right. So I think it is a question of actually not actually homogenizing the entire landscape for buildings that were one of the proposed solutions earlier, right? Okay. But to start considering these factors, and I'm pretty sure after this whole episode of COVID-19, we're going to start getting a lot more sort of social distancing rules and policies that will actually trickle down into building codes as well eventually. Right, so that becomes a function of what is the new required social space per individual as opposed to how many people you can fit within a building or within a city, which was the old way of actually looking at, housing dense populations, right? So it's going to turn a lot of dynamics around. It's going to turn the whole rural-urban migration concept around. It's going to turn urbanization around, because right now we're starting to look at possible urban conditions becoming a lot more suburban because of the need for distancing, and because hopefully some of these principles can actually be adopted, right? So does it lead to sort of more sparsely populated or less dense cityscapes? Not necessarily, right? Because the mid-height situation, of course, would be relevant for earthquake-prone environments. But if we start looking at new ways of building, new ways of modularity, we could still look at different changes in buildings. And one of the concepts I didn't have the time to share earlier was in multiple use of buildings as well, right? So in a normal situation, you have 9 to 5, your office being used. After that, in the evening, all the way up to 8 a.m. in the morning, the building is left empty, right? So multiple users of the same buildings in terms of time sharing, that too could address some of the density issues. Yeah, but it's not something that I can basically have a sort of one-stroke solution to be honest, right? And it will likely be a complex interaction of both the dynamics of I think urban planning, right, as well as how populations will grow.
Thank you very much, sir. I got your value.
Thank you. It's something I'll think about for sure. Thank you, sir.
Thank you very much. Shall we move on to Mr. Lee Ah-Ping? Do you have a question for our speakers as well?
Okay, yes. I'd like to talk about to Mr. Dr. Zuraimi. The slide just now, you show the ventilation for the HDB. The fresh air intake from the window and throughout the door. But for the old building for HDB, I don't think it's sufficient space there, because some of the building is face-to-face, main door to main door of the resident. I think the door we need to open, otherwise the ventilation is not enough. And second thing that I like to talk about the climate change. How much that we can help to improve the climate change. Because for example, now, even our HDB are on building a lot of HDB, and then pull down all the forests in Singapore. Just an example, in front of my house and companies, I have a very nice forest area. I can see the Pareva Airport, but now it's all building. So I don't think the climate won't change. Also, it's impossible. This is what I'm going to share with every one of you. Thanks.
So I'll answer the first question. So thanks for the question again. So
Yeah.
with regards to the naturally ventilated HDB blocks, we recommend to open the windows. I understand that different configurations for HDB apartments will not, will not be optimized to have that cross ventilation that you would expect if you open the front side of the house and then at the back side of the house. So under those situations, what you can do is to aid the air motion into the house by using ceiling fans or desk fans, so that the air can move into the house much more efficiently.
But my consumption become higher than that.
Some fans have quite low energy consumption, so it's way much better than using air conditioning units.
I don't use aircon, I still using fan, but if the long hour run, also the consumption is on my shoulder.
True, yeah. Well,
on your point about...
Thanks for answer. Okay, Mr. Tan, can I have?
Yes, sir, you may have your answer. I'm not sure if it's going to help you, but yeah, first of all, I'm sorry that you lost your view outside of your balcony or outside of your unit. I think when you talk about urban growth and the need to house populations, of course, that becomes a far larger discussion on whether or not the human population is increasing at a rate that becomes inequitable for the environment, right? And I think it would be difficult to discuss that within this scope, but what we actually can do as building professionals is to mitigate, I think, the impact that we're actually conducting, or mitigate the impact that we're actually putting on the environment, and mitigate the strain that we're putting on natural habitats, because that too could lead to a lot of imbalances. So as these forests are being taken away, I do hope that they are, first of all, replaced by a building that's worth that taking away, right? And the net gain that you actually get in actually housing or creating new communities will in some ways pay back for this loss of nature, especially if this nature is replaced in some ways in the building as well, right? At the very least, the building should be as efficient as possible, right? So going back to the guidelines again, and I refer to that very often because I am speaking in the capacity of the SIA today, but going back to the guidelines, I think all these actually work hand in hand to create the necessary balances that ultimately what we do as building professionals is that we're damaging the environment every single day, right? Or even as a consumer, even if we're not in the industry, we're also damaging the environment every day. So what can we actually do to mitigate that and to hopefully turn the whole wheel around once again? Yeah.
Thank you. Mr. Dr. Zhu, I got one more question that on your first slide on the cooling system intake, because you got a fresh air intake, you close up the fresh air intake to recycle the air. Is it the design for, because I'm electrical, I'm not mechanical, so I got a doubt for the return air from the exhaust to the main incoming air. Was that one is designed beforehand or afterhand?
No, what we recommend is that we want to minimize the recirculation air and maximize the outdoor air intake.
Mm-hmm.
So we don't recommend to switch off the fresh air. So that's a correction there.
Oh,
so
okay.
Yeah, so you can always minimize the recirculation air by toggle the damper openings.
Oh, okay, okay. Thank you.
Thank you, Mr. Lee.
Thank you. Thank you.
Thank you. I think there are many questions, and I am mindful that we have overrun the time of our webinar today. We've kept it to 1 hour to keep discussion tight. So perhaps we can wrap it up by taking a combination of some of the questions that are under the Q&A. I think Hann, you talked about earlier that we need to find a better balance between the environment and the human population as we build, as we occupy, and as we increase density within the environments that we stay in. So some of these can be done through guidelines. Some of these could be done through replacement, like the use of urban farming or skyrise greenery to replace some of the lost forests and green belts that we have in our environment. But also there is also a part for the users and the community to also contribute towards the positive use of buildings in generating this better balance. And there are some recommendations or some areas where we can all play a bigger part or a bigger role in this.
Absolutely, absolutely.
Yeah, definitely.
Yeah. And there's a question that came in on the online chat on the possibility of urban farming as well, in adopting the 30 by 30 or 30% food resilience in Singapore by the year 2030. I think that's a way of actually turning that wheel around again, as we talked about. So no longer does infrastructure become damaging, but it becomes augmenting to the natural environments, in this case, arable landscapes.
And from the shared systems at the larger level, whether it's a shared waste disposal system to make the entire cycle more closed in its loop, or to share facilities so that there's less wastages, better scalability. Is there more that we can do from that angle, Dr. Zuraimi?
Sorry, I didn't get the question. I was reading the other questions on the list here.
Sorry, I was just looking at from the systems angle, the active systems as a community. Is there more role for us to look at shared systems, complementary systems, among buildings, within buildings, in order to achieve better scalability and better cyclicability in the built environment sector. Maybe some recommendations?
So right now, our recommendations are mainly broad-based. It can be applied for most of the buildings in Singapore. There's some system constraints, so we need to work with some of those situations specifically. And I have received a few questions which talk about specific issues. So we cannot, basically the recommendations cannot address all of the specific issues. But I think moving forward, we will refine those our recommendation document as soon as we have more guidance material to be provided.
I think in partial response to your question as well, Su-Ming, the Resource Sustainability Act that the Ministry of Environment and Water Resources has come up with last year, I think that's going to, in some ways, influence how we look at our supply chains and how we look at how we treat the waste as well as the movement of materials as well, right? So that goes a large part towards contributing to the preservation of, natural resources as well.
Right. I think we will have to bring the discussion to a close. Is there any of the questions or the Q&A that either panelists think it's a burning question that you want to reply? I think there are quite a number of suggestions to also ask whether BCA will take into consideration some of these recommendations. The Green Mark team, I hope some of you are online with us, but generally I think BCA will take in all the recommendations as well as review the lessons that we've learned from the current pandemic, to look at them in more detail together with industry, and to look at how we will use this to inform our next version of the guidelines in order for us to design as well as operate better buildings. I think that's something that we will certainly do from BCA's angle.
And we look forward to working with BCA on this front as well.
Thank you.
I think the only point that I would like to make is, as we're continuing to understand more about the COVID-19 situation and the virus itself, and how it also operates and mutates, so too will the guidelines continue to evolve around what is the best mode of human response can actually, adapt to the situation and deal with this unfortunate situation.
Well, thank you very much. I think from both your presentations, we can see that there is already a very quick turnaround, in fact, very quick response to the evolving pandemic that we see. And from the charrette that SIA had in the last 2 weeks, as well as the work that Simple-Best is already doing, we can see the industry is actually responding and moving forward very quickly to not just respond, but actually recreate the future that we want through macro as well as all the way down to micro principles that can help us live better, that can help us live more healthily, more comfortably. So with that, I would like to thank Dr. Zuraimi and Hann again for your very enlightening sharing. With this, I'll hand over the panel back to the Secretary. Thank you.
Thank you very much.
Thank you, webinar chair and speakers, for your valuable insights, as well as all of you who have joined us today. There is indeed plenty of food for thought. We have now come to the end of our first webinar series. You will be redirected to access an evaluation form for today's session. Once submitted, you will be able to download the speaker's presentation materials. Next up in the series, we have renowned industry practitioners to share on their perspectives and strategies for areas in Design for Manufacturing and Assembly DFMA and Integrated Digital Delivery IDD on 5th and 6th May. We hope you can join us again, and we wish you a pleasant day ahead. Meanwhile, stay safe and healthy. Thank you.